This video is about curve fitting in Matlab using the command line. We're going to fit a polynomial of the order of 2, 3, and 4 on a sample dataset. First, let's load the sample dataset. I'm going to use the more dataset. And within this dataset, there are 6 columns. I'm going to just randomly use the 4th and the 5th column. Instead of typing more parentheses, colon, comma, 4, I would like to make it easier for me to use the 4th and the 5th column by assigning a variable to the 4th and the 5th column. So I'm going to use x for the 4th column and y as the 5th column. Now let's just get a feel of what the data looks like. I will plot it. Okay, x, so that I will plot a black marker with the color black. Let me run this. I'm going to name it as curve fit 2, and that's how the data looks like. As you can see, there is a bit of a correlation between x and y, so it's not exactly a linear line. Doesn't look like a linear line. It looks more like a curve, so we're going to try to fit a polynomial through it of the order of 2, 3, and 4. So how do we do that? Polynomial of the second order. I'm going to assign the fit values into P2 using this polyfit function. The first argument is the x-axis, the second argument is the y-axis, and the third argument is the order of the polynomial. So in this case it's 2. And the estimated value of the fit using the polyval function. The first argument is the output of this polyfit, and the second argument is the x values. Then let's see what that looks like. Let's try to run this first. Okay, got a value for, it calculated the values for P2 and Y2, and let's see how it looks like in a figure. So I'm gonna open up a figure window, and I'm gonna plot on top of each so we can easily compare between the different polynomial fits. First, we're gonna plot the value. And then we need to prepare these results to be in order where it'll be able to fit, be on top of the original data. So to do that, I would need to use the sort function. The sort function gives two output. One is the value that's been sorted. Second output is the index of these values. We're going to call the first one sorted var. Yeah, sorted x. And the second output is the index. We're going to call it sort index. And sort x. And then we'll plot the fit. That is the x-axis, sorted x. And then the y-axis, which is the values calculated by Matlab using this polyval function. But now it's not in the correct order, so that's why we need to use the index here. And I'm going to just make it a different color, let's say blue with a line dash dot. Let's run this. So this is the fitted line on top of the original data set. That is for the second order polynomial. For the third order polynomial, Create another variable p3 polyfit using the same data set, but now instead of the second order is the third order. And y3 polyval, the same thing. Now it's p3, still the same x-axis. Since we already sorted it once here, so there's no need to sort it again, we can still use the same sorted x. Now we just need to plot it. But now instead of y2 is y3, still use the same sort index. Let's color it green with the dash dot line, and evaluate this. By right, it should be plotted on top of this so we can compare. Yeah. Since the second order and third order is almost the same, we can barely see this, the second order polynomial fit, because the third order green line here was drawn on top of the blue line. But the blue line is still there, it's just that it's beneath this green line. I think if I zoom in, I should be able to see the blue line. Yep, there it is. Okay. Now the fourth order polynomial. Same thing as just now. Polyfit xy, but now the fourth order, and y4 polyval p4 x, and then we plot it. Y4, so we're going to color this as black, dash dot, and run this. Oh, I created another plot, but never mind. So here we can see a larger difference between the third order and the fourth order polynomials, and there's a warning here saying that this polynomial is badly conditioned because there's not enough unique x values. So sometimes you get to see this kind of results out of the polynomial fit, but it does give some recommendations here saying that you need to have more distinct x values, or we can reduce the degree of the polynomial. And we saw it just now when we did the same fit for the second order and third order. There was no such issue. Now after fitting the data, let's assess its goodness of fit to see how well it fits the data. The first test is the y prediction using the polyval function. The second is the deviation. How much does the data deviate? The third is the SST, the sum of squared terms, the total variation that should be accounted for by the fit. The fourth is the residual, basically just the difference between the actual y value and the y predicted value. The fifth is the sum of squared error. It's just the sum of the residual squared. The sixth is the normalization of the data, and the last is the r squared value. For the second order polynomial, we start off with the y prediction. And then the deviation. You see here it's y, the actual value y, minus the mean of y. So how far does the y deviate from the mean of y? And then the SST, which is the sum of the deviation to the power of 2. And then the residual, which is the deviation from the predicted. And then the sum of squared errors. which is defined as the residual to the power of 2, the sum of the residual to the power of 2. Then normalization, just the square root of the sum of squared error terms, the sum of squared errors, and then the r square. Just okay, let me run this and see. Let's take a look at the result. Oops. Okay, so I see here in my workspace I've generated the y predict 2, deviation, SST2, residual 2, and so on. Let's take a look at the normalization first. It's this value and the r square, 0.6642. And we do the same thing for the third order and fourth order. So to do that, it's the same set of commands. I'm just going to copy this, paste it, and then just make some modification to the pasted commands. So now instead of y pred 2, it would be y pred 3. Now it's the third polynomial results. Deviation is the same, SST3. This deviation is still the same as this one. Residual 3, SS23, normalization 3, r square 3, and run this. And if you remember, the third order polynomial and the second order polynomial almost overlap each other, which suggests that the goodness of fit would be the same for both of these polynomials. So let's check whether that's correct. Yes, it's about the same as norm r2 and r square 3. Also about the same as the second order polynomial. The fourth order polynomial is much different than the second and the third, so we can expect the r square and the norm r to be different. Let's do that again. Run this command. Let's take a look at the results. Yes, it is different than before. And the r square. Yep, different than the second order and the third order polynomials. So in this video, I've taught you how to fit a polynomial through a data set, and also how do we assess the fit. So that is it for this video, and if you have any comments or questions, then you can write in the comment section below. Consider giving it a like if it's useful to you, and I'll see you in the next one.